Let's take a look at this example. This time, there is no question that we're supposed to look first at the right side. So, copy this down. We have tangent theta over secant theta minus cosine theta. Because I have tangent in the numerator, I have secant in the denominator, so I'm going to convert tangent to the sine over cosine. I'm supposed to use the quotient relation, and I'm going to use the reciprocal relation to rewrite secant theta as 1 over cosine theta. So let's do it. We have sine theta over cosine theta in the numerator because it's my tangent, and in the denominator I have 1 over cosine theta because this is my secant theta minus cosine theta over 1. Someone is going to ask why I wrote cosine theta over 1, because I have fraction 1 over cosine theta, and I'm going to try to subtract from this fraction cosine theta, so it's going to be comfortable for me if I'm going to convert this cosine to fraction also. So let's take a look what we're supposed to do next. Let me copy down the top, and I have sine theta over cosine theta because I have to first organize my denominator. In order to subtract fractions, I'm supposed to find a common denominator. Common denominator for these two fractions is cosine theta. First fraction has already cosine theta in the denominator. So I'm going to just copy this down. Cosine theta minus, okay, in order to find the denominator, which has to be cosine, I have to multiply this one by cosine theta. So I'm going to have cosine theta, and whatever I did in the denominator, I have to also do in the numerator. I have to multiply this cosine theta by cosine theta. That's why I'm going to end up with cosine squared theta. Next. Now, I can rewrite this big fraction as regular division. I have sine theta over cosine theta divided by, instead of this long fraction, but I'm going to write division sign, and simply copy the denominator, 1 minus cosine squared theta over the common denominator, which is cosine theta. Look at the numerator. In the numerator, we're supposed to apply the Pythagorean relation, which says sine squared theta plus cosine squared theta is equal 1. Now, if you are going to move cosine squared theta to the right side of this relation, you are going to end up with sine squared theta equals 1 minus cosine squared theta. So instead of 1 minus cosine squared theta, I'm going to write simply sine squared theta. So let's do it. Sine theta over cosine theta. Remember, anytime we divide fractions, we're supposed to convert division to multiplication and flip the second fraction upside down. That's why I'm going to have cosine theta over, we said this has to be changed to sine squared theta. We're supposed to convert this to sine squared theta because we want to eliminate this sign. So take a look what will happen. Cosine theta and cosine theta will cancel out, and sine theta and this square will cancel. And we finally end up with 1 over sine theta. 1 over sine theta is equal cosecant theta. Now, let's take a look what we have got over here and what we have on the left side of the original equation. We got exactly the same cosecant theta. It means that we proved that the left side of the equation is equal to the right side. Let's take a look at this example. We're supposed to start proving that the left side is equal to the right side from the left side because it's the more complex one. So what I have to do first, simply copy this down. Tangent squared theta minus 1 over 1 minus cotangent squared theta. Now, I have fraction and I have cotangent in the denominator. So what I'm going to do, I'm going to copy down the numerator and I have tangent squared theta minus 1 and I have 1 minus, and instead of cotangent squared theta, I'm going to use the reciprocal relation, which is allowing me to write cotangent squared theta as 1 over tangent square theta. Now, this is equal. I have 1 and I have fraction. So what I'm going to do, I'm going to write tangent squared theta minus 1 over 1 over 1. I have to convert this one to fraction because I have fraction over here, minus 1 over tangent square theta. In order to subtract these two fractions, I'm supposed to find a common denominator. Common denominator is tangent square theta. I have tangent square theta minus 1 in the numerator over, and the common denominator for these two fractions is tangent square theta. Tangent square theta minus 1 over tangent square theta. We simply multiply 1 by tangent square theta in order to find a common denominator. So whatever we did in the denominator, we have to do also in the numerator. That's why in the numerator I'm going to have also tangent square theta. Copy the numerator and we have tangent square theta minus 1 over, now we can perform the subtraction. I'm going to have tangent square theta minus 1 over common denominator, which is simply tangent square theta. Tangent square theta. Now, we have division. In the denominator, I have fraction. I'm going to rewrite the whole fraction as the regular division. So I'm going to have tangent square theta minus 1 over 1. I convert the numerator to fraction because I have a fraction in the denominator. And anytime we perform the division of fraction, we're supposed to copy the first one down, and the division sign we have to change to the multiplication and multiply the first fraction by the reciprocal of the second fraction. We have tangent square theta over tangent square theta minus 1. We have multiplication, and we have in the numerator tangent square theta minus 1, and in the denominator of this fraction tangent square theta minus 1. That's why I can cancel them out and perform multiplication. It's going to be 1 times tangent square theta is tangent square theta over 1 times 1 gives me 1. Tangent square theta over 1 is tangent square theta. Now let's take a look what we have got and look at the original equation. We got exactly the same function, trigonometric function. So means that we proved that the left side of my equation is equal to the right one.